4z equal to 12, which is in the first octant, The screen is visible and voice is clear.
Yes, sir.
Okay. Now this is surface integral. In place of ds, the notation dA is given. That's it. That is the difference. And see this problem. I have to evaluate this surface integral where vector is given, f bar is given. And what is S? This S. What is this S? It is the portion of the plane. S is actually surface. And what is the surface is given as? Portion of the plane 2x plus 3y plus 4z, which is in the first octant. Therefore, first thing, given surface is phi of xyz is equal to, what is this? 2x plus 3y plus 4z minus 12. This is the surface equation. And what is this n bar here? You know, n bar is the unit normal to the surface, yes, to the surface phi, Therefore, what is n bar? Unit normal is del phi and unit normal is mod del phi. Okay. Therefore, what is del phi first? I dou phi by dou x plus j dou phi by dou y plus k dou phi by dou z. That is equal to, what is this? I into dou phi by dou x means 2, dou phi by dou y 3j, and this is 4k. This is del phi. Therefore, what is n bar is equal to 2i plus 3j plus 4k by root over 4 plus 9 plus 16. So this is 2i plus 3j plus 4k whole by root 29. This is unit normal vector is over. Next one, what is this? I have to calculate f bar dot n bar. Which is inside the integration. What is f bar is given as 6zi plus 6j plus 3yk dot 2i plus 3j plus 4k over root 29. That is equal to 1 over root 29. This is what? 12z you will get first term, and 18 next one 12y. This is f bar dot n bar. Now I told you how to evaluate this surface integral. What is this? To evaluate this, take the orthogonal projection of S on any one of the coordinate planes. Let's take orthogonal projection of yes on xy plane. Then what is this? Double integral over yes f bar dot n bar ds dA equal to double integral over r defines projection on xy plane. F bar dot n bar, if I take projection on xy plane, in the last class I have given you this is dx dy by, for xy plane what is the unit perpendicular vector? K bar. Take dot product with n bar. This is the formula, right? Okay, so what is this happens now? This equal to double integral over a f bar dot n bar dA is equal to double integral over r. What is f bar dot n bar? Already calculated. What is that? 12z 12z 18 plus 2y, 12z plus 18 plus 12y, okay, by 1 by root 29 outside dx dy by n bar dot k bar. Okay, this is what is n bar dot k bar. See, what is n bar? N bar is this one. N bar dot k bar means what you will get? 4 by 29 you will get. 4 by root 29. 4 by root 29. Still any doubt? In bracket, since n bar dot k bar equal to n bar dot k bar. What is n bar? 1 by root 29 of 2I plus 3j plus 4k dot k bar. So dot k bar dot k bar is 1. Okay. K bar dot k bar is 1. Therefore, this is 4 by root 29. Done. So this 1 by root 29, 1 by root 29 gets cancelled. This equal to double integral over r 12z plus 18 plus 12y. 12y dx dy and 1 by 4 comes outside. Right? Here, what is r? Clearly, you write down here r is the orthogonal projection of the surface phi on xy plane. On xy plane. What is xy plane means? Z equal to 0. And one more important point, all of you, before writing this, yeah, let me clarify this. Here, see here integration with respect to dx dy. There is one z term is here. I have to eliminate that z term from the surface equation. Don't put 0 here. Everything goes wrong in integrand. From the surface equation, okay. From the surface equation, what is z equal to 2x plus? That means minus. What is the right side value? 12. So from the surface equation, this is 12 minus 2x minus 3y by 4. Substitute here. Okay. Therefore, double integral over s f bar dot n bar ds is equal to 1 over 4 double integral over r. What is this? Becomes 12 by 4 means 3. 3 means this is 36 minus 6x minus 9y. This is about z plus 18 plus 12y, this whole bracket closed, dx dy. Dx dy. Understood? This is equal to 1 over 4 double integral over r. What is the whatever the constant? 36 plus 18. This is 54. And only minus 6x coming to 9 minus 9y plus 12y. This is 3y dx dy. Now a problem is completely in terms of x and y. Now you write here. Here r is the orthogonal. R is the orthogonal projection of S on xy plane. On xy plane, right? That is on xy plane means what? Z equal to 0. Therefore r is, what is r is? Actually, what is the equation? R is, what is the surface equation? 2x plus 3y plus 4z equal to how much? 12, where z equal to 0. That implies what is r becomes 2x plus 3y equal to 12. R becomes 2x plus 3y equal to 12. Okay. And 12, therefore r is the region bounded in first quadrant, that is given is first octant, bounded in first quadrant by, what is the line? 2x plus 3y equal to 12. That means what is the figure? Obviously, what is this? 2x plus 3y equal to 12 means this is 6 and this is 4 if I take. So this is the straight line. This is what the straight line? 2x plus 3y equal to 12. X intercept 6 and y intercept this one. Okay. So what is the region? This is the region bounded. This is R. So if I consider vertical strip in this one, okay, all these things, you know, so I'm not giving a clear explanation, just limits of over R, limits for y are, what are the limits? By considering vertical strip, y equal to 0 to y equal to, what is from straight line equation, what is y value? 12 minus 2x by 3. And limits of x are x equal to 0 to x equal to how much? This is 6. X intercept 6. This value 6. Therefore, double integral over s f bar dot n bar ds equal to 1 over 4. Now you write the limits y equal to 0 to 12 minus 2x over 3 and x equal to 0 to 6. And what is integrand? 54 6 3y. 54 minus 6x plus 3y. First dy, then dx. Okay, so integration, you know the techniques, 0 to 6, and this is integration first with respect to y. So 54 minus 6x treated as constant y between what limits? 0 to, what is the limit? 12 minus 2x by 3 plus 3 by 2 y square limits between 12 minus 3x by 3 12 minus 2x by 3, this entire dx. So this is equal to 1 over 4 integral 0 to 6. First, this 54 minus 6x as usual, upper limit minus lower limit gives 12 minus 12x by 3 plus 3 by 2, and this is 12 minus 2x whole square by 9 you will take. This is dx. Okay, now you have to simplify this entire thing. This equal to what? This is 3 1s are 3 3s are, so 1 by 3 I can take outside, so becomes 1 by 12, and 0 to 6. Let us multiply everything and simplify it. What you will get, it's a big one. I have to multiply entire thing, so I'm giving anyway. I did this problem. This is 1 over 6 360 minus 102x plus 7x square. This is the final expression. Okay, and if I substitute integrating this, 1 over 6 360x 102 by 2 means what is this becomes? By 102 51 x square 7x cube by 3 between 0 to 6. The answer is 138. Answer is 138. This is one problem. See, once again, briefly, what is that? Evaluate the surface integral where f bar is given, and what is the surface is given as the portion of the plane 2x plus 3y plus 4z equal to 12, which is in the first octant. So first, let us identify the surface. What is the surface? This is the surface in the first octant. And for this surface, let us find the first. I have to evaluate this f bar dot n bar. So for that, let me calculate n bar first. N bar means unit normal vector del phi by mod del phi. Therefore, and its value is this one. Then take f bar dot n bar. I'm getting f bar dot n bar is over, right? To evaluate the surface integral, definitely we have to consider orthogonal projection of s on any one of the coordinate planes. I'm taking the projection on xy plane. So what is the formula? The surface integral reduces to this one. Then let us substitute everything, f bar dot n bar and dx dy. N bar dot k bar is 4 by 29, and after simplification I'm getting this. And since integration is with respect to x and y, I have to eliminate z. Always remember, in the integrand means inside the integration, eliminate z value from the surface equation. So from the surface equation, the z is this value. Substituting this and simplifying, I'm getting integrand completely in terms of x and y. So, and what is the r? R is the projection on xy plane. On xy plane, what is the value of z? 0. So the plane becomes circle, not straight line. Straight line and area bounded in the first quadrant, because the surface is in the first octant. The corresponding projection is in the first quadrant. So by considering vertical strip, I got these limits and evaluating and calculations, I'm getting answer 138. This is one problem. Next, another one. Any doubts? evaluate the surface integral double integral over s f bar dot n bar ds, where f bar is equal to z square I plus xyj minus y square k, and s is the s is the portion of the surface of the cylinder. S is the portion of the surface of the cylinder x square plus y square equal to 36, 0 less than or equal to z less than or equal to 4, included in the first octant. Included in the first octant. Included in the first octant. Okay. Now, solution. First, what is the surface here? Is it is given as, see, just I will show a rough figure for this. This is 0. I'm taking this as, let me take x-axis, and this is y-axis, and this is z-axis. Clearly, the cylinder is symmetric about z-axis. So let me draw one cylinder with center. This is the cylinder. Done. And clearly, what is given? Z equal to 0. Z equal to 0 to Z equal to 4 maximum value. Z equal to 4. Z equal to 0 and up to 4. Let me consider 4. For example, this is 4. This is 4. And Z equal to 0 here. Z equal to 0 to 4. So I have to consider which portion of the surface? Only this part of the surface. Only this above one, not below one. Okay. So first one, the surface is phi of xyz equal to x square plus y square minus 36. X square minus y square minus 36. Okay. Then what is the normal? Then n bar equal to del phi by mod del phi. What is del phi? I dou by dou x, that is 2xi. I dou by dou y, that is 2yj plus j dou by j is not there. Z is not there, therefore 0. So del phi is over. Therefore, what is n bar equal to 2xi plus 2yj by root over 4x square plus 4y square. 4x square plus 4y square. This is 2 of xi plus yj by 2 of root over x square plus y square. So this is xi plus yj by, what is x square plus y square? From the curve equation 36 is given. Okay. So let me substitute that value, root 36. So unit normal is what? Xi plus yj by 6 is the unit normal to the surface phi. Unit normal to the surface phi. Now, to evaluate,
sir.
what?
By 2 into root x square plus y square, no, sir.
2 gets cancelled, no?
Yes, sir.
Now, to evaluate the surface integral, see this problem, this is some logic is here. To evaluate the surface integral, take the orthogonal projection of, yes, on which plane? For example, if I consider xy plane, don't write, actually this is wrong statement. on xy plane. What we have then, see, I will write double integral over s f bar dot n bar ds is equal to double integral over r f bar dot n bar is what? Finally, what we got? Oh, we have not calculated. What is f bar is here? What is f bar? Z square I plus xyj minus y square k dot, what is this, xi plus yj by 6. This is becomes what? Dx dy by n bar dot k bar. This is the formula, n bar dot k bar. Okay, right? But see, what is n bar is here? Clearly it is here. N bar is what? This one is n bar. If I take dot product with k bar, what is this value? This becomes 0. This becomes 0. So this is for our idea. I'm not cancelling this. It is a wrong statement. Keep in brackets. It is a wrong statement. If I take our xy plane, this n bar dot k bar becomes 0. So entire integral cannot be evaluated. Right? This cannot be evaluated. This cannot be evaluated, as n bar dot k bar is what? 0. Okay. Therefore, taking projection on xy plane is wrong. Then which one? Clearly seeing, what is this? Z is varying from z equal to 0 to z equal to 4. Z equal to 0 to z equal to 4. This is the one idea. So I have to consider orthogonal. Therefore, take orthogonal projection. Take orthogonal projection of S on your choice. Which plane? YZ plane or ZX plane? Z must be included. On, let me take YZ plane. YZ plane. Then, what is the surface integral? Becomes formula double integral over S f bar dot n bar ds is equal to double integral over r f bar dot n bar. What is YZ plane? Dy dz by, for yz plane, what is the vector? This is j and this is k. Therefore, I bar, n bar dot I bar, n bar dot I bar. So let me calculate one by one. F bar dot n bar, take this as 1. F bar dot n bar, f bar dot means this is z square I plus xyj minus y square k dot n bar. What is n bar? Xi plus yj by 6. So what this becomes? Z square x plus xy square, xy square by 6 by 6. F bar dot n bar is over. Then next one, n bar dot I bar. Now n bar dot I bar, this is xi plus yj by 6 dot I bar. That is nothing but x by 6. That is nothing but x by 6. Therefore, equation 1 implies what this becomes? F double integral over s f bar dot n bar ds is equal to double integral over r. What is this? I can write this x common here. X is common, so I can write y square plus z square by 6. Right? So this is y square plus z square over 6. F bar dot n bar is over dy dz by x by 6 by x by 6. So this x by 6 gets cancelled completely. Then remember, see, on yz plane, what is r? R is on yz plane. So integrand must be in terms of y and z only. This is very, very important. What is our projection on yz plane? So integration is with respect to yz, and this function must be function of yz only. Okay, and remove x term from the equation of the surface. But in this problem, automatically the x terms are getting cancelled. So don't bother. Okay. So what is this is equal to double integral over r y square plus z square dy dz. Y square plus z square dy dz. Any corrections? Right? Here what is r? Where r is the projection on yz plane. On yz plane, bounded by what is this? Circle. Now it is two-dimension YZ plane bounded by the circle x square plus y square equal to 16. What is that? 36. X square plus y square equal to 36, and z varies from 0 to 4. Z varies from 0 to 4. Let me write clearly. On YZ plane x equal to 0. On YZ plane x equal to 0. Therefore, x square plus y square equal to 36 becomes what? Y square equal to 36. This implies y equal to plus or minus 6. This part, there is no x term now. Therefore, but in the question it is given first octant. Therefore, and you write here orthoprojection projection of on YZ plane on positive quadrant of YZ plane, positive quadrant of YZ plane. Therefore, on positive quadrant of YZ plane, Y varies from 0 to 6 and Z varies from 0 to 4. It is clearly given. Okay, therefore, double integral over S f bar dot n bar ds is equal to, now choice was limits are constants. You can evaluate with respect to any variable because limits are constant. And what is this? Y square plus z square dy dz. dy dz. Okay. So if I evaluate with respect to z y first, then this is y cube by 3 plus yz square between 0 to 6 and dz. So this is 0 to 4. This is 6 cube. 6 cube by 3 means 72 plus this is 6 z square. 72 plus 6 z square and lower limit 0 dz. So this is 72 z cube by 3, 2z cube between 0 to 4. 0 to 4. Answer is 416. Answer is 416. These are the problems based on surface integrals. Okay. I will give anyway assignment on the surface integral. Now, that's easy, no problem. Yeah. The next one, Green's theorem. Green's theorem in plane. Green's theorem in the plane. Statement is important for 2 marks. What is the statement? Niharika, are you there?
Yes, sir.
Are you understood these 2 problems?
Yes, sir.
Okay, practice this. Next, Green's theorem in the plane. The statement is, just give me a minute. Notations are important here. F and G is given. Okay, doesn't matter. Statement. Let C be a piecewise smooth, simple closed curve. Let me write like this instead of that. Okay. Let C be a, capital C be a piecewise smooth closed curve bounding a region R. Bounding a region R. If f of x comma y, g of x comma y, dou f by dou y, dou g by dou x, dou g by dou x are continuous on R, are continuous on region R, then continuous on region R, then the circulation over C, closed curve C, f of x comma y dx plus g of x comma y dy, f of x comma y dx plus g of x comma y dy is equal to double integral over R dou g by dou x minus dou f by dou y dx dy. Dou g by dou x minus dou f by dou y dx dy. Okay, see the statement. What is curve C is given as? Curve C is piecewise smooth closed curve. It is a closed curve, and a piecewise smooth means piecewise continuous. The curve is piecewisely continuous closed curve, and it is enclosing a region R. It is enclosing a region R. This one. Remember, simple closed curve. Simple closed curve, or yeah, this is piecewise smooth. Simple term is there. Simple must be there. Piecewise smooth. Simple. What is meant by simple closed curve? Which does not intersect itself. Which does not intersect itself like this. Okay, it must be continuous. And this is the reason R bounded by closed curve C. Then, and on this closed curve, f and g are continuous functions. F and g both are continuous functions. And one more, what is the condition is here? See, which derivatives are on the right side? Dou f by dou y and dou g by dou x. These two derivatives are enough. These two must be continuous on the region R. Then, so for your to remember, I'm giving one logic. What is this? How to remember? Hint. Hint is circulation over C, f dx plus g dy. Double integral over R. First f is there now, next g is there now. Write g derivative. What is g? Is the quotient of dy. Then take g derivative with respect to x. Dou g by dou x minus dou f by dou y minus f derivative with respect to y. It is the quotient of dx. Then dx dy. This is the idea to remember Green's theorem statement. And what it gives? It gives relation between line and double integral. Line and double integral. Line and double integral. And what is the use of this Green's theorem? See, in classroom we did one problem. Evaluate the line integral over the triangle. Do you remember? Over the triangle, right? There we consider the curve C as three parts: line C1, line C2, line C3. I have to evaluate over each line C1, C2, C3. But if I if I transform that line integral, this line integral to double integral, directly I can evaluate. Not three times, one single time. That is the benefit of Green's theorem. Now, for example, see, let me consider one problem. Yeah, take this. Evaluate circulation over C, x square plus y square dx plus y plus 2x dy. See, the structure must be like this. The structure of left side must be f dx plus g dy. If it must be that form, not any other form. And remember, what is this? Let me tell you. Just this idea. What is this? I'm giving here. This f dx plus g dy means integral f dx plus g dy. I can write this as integral over C fi plus gj and a dot dxi plus dyj, isn't it? So what is this? This is nothing but integral f bar dot dr bar, line integral, isn't it? That is why I told you this gives a relation between line and double integral. So this is the line integral. Left side is of the form f bar dot dr bar. You have to remember this, f bar dot dr bar. Now, coming to this problem, x square y square dx plus y plus 2x dy, where C is given definitely, where C is along, where C is the boundary of the region. C is the boundary of the region. C is the boundary of the region in the first quadrant. In the first quadrant, that is bounded by the curves y square equal to x and x square equal to y square equal to x and x square equal to y and x square equal to y. Solution. First thing, here let me write what is f value. F of x comma y is what? X dx quotient. This is dx quotient, so this is f of x comma y, and g of x comma y is what? Y plus 2x. See in the problem, remember in the problem, apply Green's theorem is not given. Evaluation of line integral. And what is curve C here? C is the boundary of the region in the first quadrant. Let me draw. Between bounded by y square equal to x, this is the curve y square equal to x, and x square equal to y. This is x square equal to y. So this is y square equal to x, and this is x square equal to y. So this is the region. This is the region bounded by these two parabolas. This is R. This is R. If I want to apply line integral, jagrata vinandi concept. If I don't want to apply Green's theorem, then what is the curve C? Curve C is the boundary. So I'm tracing this. See, curve C is the boundary of the region bounded by these two parabolas. This is the curve C. So C is the join of what? C is the join of C1 and C2. C1 and C2. This is curve C1 and this is curve C2, correct? So to evaluate the line integral, I have to evaluate into two curves, over C1 and over C2. Okay, just I am mentioning that. If we want to evaluate, don't write in examination this is, okay? If we want to evaluate as line integral, we have to evaluate on C1 and C2 separately and add them to get integral over C f bar dot dr bar. This is idea. This is as line integral. But if I want to apply Green's theorem, what is this? But by using Green's theorem, we convert the line integral. To double integral, where we can decide the limits of x and y over R. Simple. Okay, that's better. Therefore, by Green's theorem, what we have? Circulation over C f dx plus g dy is equal to what? Double integral for E. First write G. Dou G by, this is y means, y dy quotient means with respect to x, and f derivative with respect to y, dx dy. Okay. Therefore, what is f of x comma y in our problem? F of x comma y, it is the quotient of x square dx. From this you calculate dou f by dou y is enough, that is 2y. And what is g of x comma y is equal to, what is that? Y plus 2x. I need dou g by dou x, that is equal to 2. That is equal to 2. Okay, therefore, by Green's theorem, circulation over C, what is our problem? X square plus y square dx plus y plus 2x dy, equal to double integral over R, okay, dou g by dou x minus dou f by dou y dx dy, and over R by considering vertical strip, over R by considering vertical strip, limit y r, see what is this? This is vertical strip. Let me consider vertical strip. This is the vertical strip. Okay, so lower limit lies on y equal to x square, upper limit lies on y square equal to x. Okay, limits of y are y equal to x square to y equal to what? Root x, upper limit, root x, and limits of x are x equal to 0 to 1. Okay, this value is 1. What is this? This point is 1 comma 1. This point is 1 comma 1. So 0 to this value 1. Hence this equal to, therefore in circulation over C, x square plus y square ax, y plus 2x dy is equal to double integral y equal to x square to root x equal to 0 to 1, 2 minus 2y, first dy, then dx, that is equal to 0 to 1, this is 2y minus y square between x square to root x dx, that is equal to 0 to 1, 2 into what is this? Root x minus x square minus x minus x power 4, this total dx, isn't it? Okay, so if I apply everything, if I simplify this, this is 2 x power 3 by 2 by 3 by 2 minus 2x cube by 3 minus x square by 2 plus x power 5 by 5, 0 to 1, 0 to 1. So what this becomes? This is equal to, only upper limit will be there. This becomes 4 by 3 minus 2 by 3 minus 1 by 2 plus 1 by 5. This is 11 by 30. 11 by 30. Okay. Next problem. Let me take e power x where c is, yeah, that's also easy. Next problem. Oh, verify Green's theorem. It's a big one. Verify Green's theorem. Verification for f of x comma y equal to e power minus x sin y, g of xy equal to e power minus x cos y, and c is the square. C is the square with vertices. C is the square with vertices at 0 comma 0, pi by 2 comma 0, pi by 2, pi by 2, 0 pi by 2, 0 pi by 2. Solution. We have to prove that. Verify Green's theorem means we have to prove that circulation over C f dx plus g dy equal to double integral over R dou g by dou x minus dou f by dou y dx dy, equation 1. So I have to prove LHS, I have to find LHS value, that is LHS equal to RHS of Green's theorem. of Green's theorem. That first, let me write LHS. What is LHS? Integral over C f dx plus g dy. F dx plus g dy. Where C is what? C is the boundary of the square. C is the boundary of the square with vertices 0 0, pi over 2 0, pi over 2, pi over 2, 0, pi over 2. Right? Let me draw the figure. This is x-axis, this is y-axis, this is 0. I'm taking this as pi by 2, 0, just for idea. This is 0, pi by 2. So this becomes what? Pi by 2, pi by 2. Done. So this is the square. This is the square. This is 4, 0, 0. Let me take this A, this is B, and this is C. Right? What is C is now boundary. Therefore, I have to consider what? C1, C2, always anti-clockwise, as I told you in the classroom. This is C4. Clearly write down. Here C is the join of, here C is the join of C1, C2, C3, C4. C1, C2, C3, C4. So I have to evaluate all these, the integrand. I have to evaluate the integrand over these 4 parts now. Over C1, first one. Equation of C1 is, what is that? In the figure C, equation C1 means x-axis, y equal to 0. Y equal to 0 means what? Dy equal to 0. Right? And so y is eliminated. X varies from 0 to pi by 2 over C over S1. Therefore, integral over C1, what is the value? F dx plus g dy. Let me calculate. So this is 0 to pi by 2. What is f? E power minus x sin y dx, e power minus x cos y dy. And what is y value? 0. You have to substitute here. 0 to pi by 2. Y value 0 means first one 0 dx. Y value 0 means e power, this is, and dy 0. E power minus x 1 and the dy value 0. So what is this entire value? 0. First one is over. If any doubts, you raise the questions. Over C2. Equation of C2 is, what is that equation of C2? This one. Okay, let me write. Equation of C2. What is this C2? Parallel to y-axis at a distance pi by 2. So this value is x equal to pi by 2. And this value is, this line is y equal to pi by 2. And this is x equal to 0. And this is y equal to 0. C2 x equal to pi by 2. Right? Equation of C2 is x equal to pi by 2. This implies what is dx equal to 0. So we are eliminating x. So remaining variable y varies from where to where? 0 to pi by 2. 0 means 0 to pi by 2. See, over C2, y varies from this 0 to pi by 2. Right? Therefore, integral over C2 f dx plus g dy is equal to y equal to 0 to pi by 2. Already it is here. E power minus x sin y dx plus e power minus x cos y dy. Sorry. Cos y dy. So what is this? X equal to pi by 2 and dx equal to 0. So first term is what? Dx equal 0 means this part 0. And what is x equal to pi by 2? Plus e power minus pi by 2 cos y will be there, dy. Yeah? So this is e power minus pi by 2 outside, cos y integration sin y between 0 to pi by 2. So only e power minus pi by 2 will be there. E power minus pi by 2 is the second integral answer. Now over C3. Equation of C3 is, what is C3 equation parallel to that? Parallel to x-axis. So y equal to pi by 2, dy equal to 0. So integral over C3 f dx plus g dy is equal to, this is, and x varies from anti-clockwise, pi by 2 to 0. So x equal to pi by 2 to 0. And what is this becomes? E power minus x sin y dx, e power minus x cos y dy. So what is this is equal to pi by 2 to 0. Y value pi by 2, dy value 0. Second term will be 0. This is e power minus x, and sin pi by 2 dx will be there, and dy 0. dy 0. So what is this value? E power minus x from pi by 2 to 0. That is equal to 1 minus e power minus pi by 2. 1 minus e power minus pi by 2. What is this? Any change?
Sir, into minus will be no, sir, integration.
Where? That's why. E power minus x integration minus will be there. E power minus pi by 2 minus 1. This is over C3 is over. Next one. Last one. Over C4. Equation of C4 is what? It is y-axis. X equal to 0, dx equal to 0. So y varies from, that upper is what? 0 pi by 2. Pi by 2 to 0. Therefore, over C4, f dx plus g dy is equal to, this is y equal to pi by 2 to 0, e power minus x sin y dx, e power minus x cos y dy. So this value pi by 2 to 0, dx value 0, first one is 0, x is 0, so simply cos y will be there. Minus 1. After substituting limits, what is the value? Negative 1. So therefore, circulation over C, f dx plus g dy is equal to over C1 f dx plus g dy plus over C2 f dx plus g dy plus over C3 f dx plus g dy plus over C4 f dx plus g dy. So one by one, what is the first one answer? Over C1, what is the answer? 0.
0.
Over C2, what is the answer? E power minus pi by 2. Over C3, what is the answer? E power minus pi by 2 minus 1. And over C4, what is the answer? Negative 1. So finally, what I am having? 2 into e power minus pi by 2 minus 2. Correct? This is the value of LHS. This is the value of LHS. Now coming to RHS. Coming to RHS. What is that? Double integral over R dou g by dou x minus dou f by dou y dx dy, where R is the region bounded by square, as shown in figure, the first figure itself. Okay, right? If you want to draw once again, you can draw. What is this? This is the figure. This is 0, pi by 2 0, pi by 2 pi by 2, right? And 0 pi by 2. This is R. You consider one vertical strip. Okay, this is y equal to 0, and what is this value? Y equal to pi by 2. That's it, enough. Therefore, limits of y are, by considering vertical strip, limits of y are y equal to 0 to pi by 2. Limits of x are also x equal to 0 to pi by 2. And I have to calculate dou g by dou x, dou f by dou y. What is f of x comma y? E power minus x sine y. I need what? Only dou f by dou y is needed. Next, g of x comma y, e power minus x cosine y. So dou g by dou x is what? Minus e power minus x cosine y, right? Therefore, double integral over R dou g by dou x minus dou f by dou y dx dy is equal to first y limits 0 to pi by 2, x limits 0 to pi by 2, dou g by dou x minus dou g by dou y dy dx. You can take dx dy also, doesn't matter. This is equal to, both are same now, so minus 2 outside, 0 to pi by 2, 0 to pi by 2, e power minus x cosine y dy dx. So minus 2 into 0 to pi by 2, e power minus x constant, cosine y derivative, sine y 0 to pi by 2 dx. Next, thus it is equal to negative 2, 0 to pi by 2 e to the power of minus x 1 minus 0 dx. So minus 2 e power minus x by negative 1, 0 to pi by 2, right? That is 2 into e power minus x between 0 to pi by 2. So 2 into e power minus pi by 2 minus 1. This is RHS value. Since LHS equal to RHS, Green's theorem is verified. Green's theorem is verified. Okay, this is one model problem in Green's theorem. You take this as assignment. First one, verify Green's theorem. GT stands for Green's theorem. For integral over C xy plus y square dx x square dy, where C is bounded by y equal to x and y equal to x square. Y equal to x and y equal to x square. Next problem. This is also important. Second one, this is important. It's solved problem in textbook. Using Green's theorem, evaluate integral over C y minus sin x. So circulation, if its circulation is not given, you assume always closed it. Okay, sin x dx plus cos x dy, where C is the plane triangle. C is the plane triangle enclosed by the lines y equal to 0, x equal to pi by 2, and y equal to 2 by pi x. Now the verification, what is this? Is using Green's theorem means convert this line integral to double integral. This is f and this is g. Okay, so what is the shape of the figure here? Y equal to 0, nothing but x axis. X equal to pi by 2, that is line parallel to y axis. This is pi by 2 if I take, and y equal to mx line. this is y equal to 2 by pi x, and this is x equal to pi by 2, x equal to pi by 2. Therefore this value is x value pi by 2 and y value 1. This is the region R. That's it. Okay, you consider vertical step and evaluate it. Okay, answer I'm giving minus of pi by 4 plus 2 by pi. Nagakshita, are you there?
Yes, sir.
You solve these assignment problems and post it in the group.
Okay, sir.
Step by step. Okay, don't
Okay,
cut it, don't cut the steps. Third one also. Okay, apply
Okay,
Green's theorem. Apply Green's theorem to evaluate integral over C 2x square minus y square dx plus x square plus y square dy, where C is the boundary of the area enclosed by the x-axis and the upper half of the circle, x square plus y square equal to a square. X square plus y square equal to a square. Okay, just I'm giving hint for this. What is the area bounded by? This is x-axis, and if I take this as y-axis, upper half of the circle, this is upper half of the circle, this is x square plus y square equal to a square, and x-axis. So this entire is the region R. So what is this value? Just I'm giving hint. The circulation over this is all equal to what? Double integral. This is f and this is g, right? Dou g by dou x, dou g by dou x minus dou f by dou y minus 2y. You will get dx dy, isn't it? Right? Now you consider vertical step in this region. This is negative a to positive a. That's it. Enough. Those are the limits. I'm giving limits also. X equal to negative a to positive a. And what about y? Definitely this is 0 only. And upper limit lies on what? Circle. Positive. Y is positive upper half. A square minus x square. 2 outside. X plus y dx dy. X plus y dx dy. Evaluate this. Answer is 4a cube by 3. 4a cube by 3. Okay, solve clearly and post it. And next one, apply Green's theorem to prove that area enclosed by a plane curve is 1 by 2 over closed curve seen x dy minus y dx. X dy minus y dx. Hence find the area of an ellipse. The area of an ellipse whose semi-major and semi-minor axes are of lengths a and b. Nothing but what is the ellipse equation? X square by a square plus y square by b square. That's it. This how many? 4 problems are assignment. And remember, for the 4th problem, I am giving hint. you consider this integral first. Forget about half. This is of the form, what is this? mdx plus fdx plus gdy. What is f value? Just hint is what? Take f equal to minus y, g equal to x. Apply Green's theorem. That's it. You will get this value. Okay. Next. Okay. With this, Green's theorem is finished. Any doubts? Any doubts? And more problems are there, but similar problems are there. Okay. Anyway, I will give for this one hint. This is what? Take f equal to minus y, g equal to x, then dou f by dou y value -1, dou g by dou x value 1. By Green's theorem, what we have? Integral over c f dx plus g dy is equal to what? Double integral over r dou g by dou x minus dou f by dou y dx dy is there. So if I substitute, what is dou g by dou x? 1 minus of minus 1, this is dx dy. So this is 2 into double integral over r dx dy. What is double integral over r dx dy? This is nothing but area of the region R. Area of the region R. This implies, so what is this is? Integral over c, and what is f I have taken? F I have taken minus y. So this is minus y dx plus x dy. So what is this answer? What is the, therefore, area enclosed by a plane curve C is what? This area equal to 1 by 2 integral over c x dy minus y dx. Take this to this side. This is area of the region R bounded by a plane curve C. Plane curve C. That's it. This is the area formula. Done. And ellipse. Another one is, what is the ellipse equation? X square by a square plus y square by b square equal to 1. X square by a square plus y square by b square equal to 1. You find that area. What you have to get? Definitely pi ab. Area formula is this. Okay. To get that, since it is a line integral, put x equal to a cos t, y equal to b sin t. That's also I'm giving, saying everything. Dx equal to what? Minus a sin t dt. Dy equal to what? B cos t dt. So what is the area of the ellipse? Therefore, area of ellipse equal to 1 by 2 integral over c. What is the formula? X dy minus y dx. So substitute everything. And the t varies, you know. T varies from what? Total ellipse means 0 to 2 pi, right? So 1 by 2, 0 to 2 pi, x equal to a cos t, and the dy b cos t. So ab cos square minus y equal to b sin t, and dx equal to what? Minus. So ab sin square. And what is this? Dt is common entirely. So this is equal to what? ab by 2 integral 0 to 2 pi dt cos square plus sin square. So this is ab by 2, t lies between 0 to 2 pi. So pi ab is the answer. Pi ab is the answer. Okay, with this I will stop. Any doubts? Green's theorem is finished, and practice these problems. Definitely one problem will come from Green's theorem in annual examination. In the next class, I will complete Stokes theorem, and Saturday also I will take 1 hour. That last theorem, Gauss divergence theorem. Okay. Any doubts? Shall I stop?